So today I'm going to tell you about the Airgap and the Zscaler family of security. As you may know, the Airgap is one of the latest additions to the Zscaler family, and we are the on-prem security device that you can use to help securing your network. And I'm given this before lunch sessions, so hopefully I can give you some food for thought before we could go out for food, the actual food. Lunch is actually a good place to start the Airgap origin story if I can get to the slide. Okay, so Airgap founders Ritesh and Vinay used to work at Juniper Networks on the SRX product lines of security appliances. And one day, they asked themselves, how can we do better? And the answer was lunch. So they went out to lunch, and they were talking about how in the mobile networks, in the cellular networks, how they can have the security of the devices and not have any lateral threat in their network. The answer is the architecture of all the cellular devices needs to talk to the tower. And the tower will be responsible for forwarding the traffic to any other devices in the network. And that is the segment of one architecture. And they thought to themselves, can they bring that segment of one architecture to the regular networks to benefit from that architecture? That was their eureka moment. And with that, they went back to the TCP/IP standard and the DHCP standard and found a solution. Using DHCP, if the Airgap security appliance can assign the devices into their segment of one, then they can achieve the east-west firewall in the regular network. Let's look at how it fits into the Zscaler security framework. The Zscaler security framework has 4 areas of zero trust segmentation. The first one is the user segmentation. When the users log in, all their data will go into the zero trust exchange, and the zero trust exchange will determine where they can go in the rest of the network. The second area is the workload segmentation. And that means for the applications and functions, the zero trust exchange will determine whether those applications function can talk to any other functions in the network. The third area is the branch or the campus segmentation. And this is obviously by location. And the data from any of these locations will be sent into the zero trust exchange. And the zero trust exchange will determine where they can go. And the branch or the campus can be geographical or virtual. Lastly, we have the device segmentation. And this is where the Airgap security appliance comes in. As you can see, we have all the devices connecting to the same VLAN or subnet. So within the same VLAN and the subnet, they can see each other. So how can we do the segment of one segmentation so that all the devices can be segmented on the device level? And that's where the Airgap security appliance DHCP comes in. With the devices on board onto the network, they will be asking for the IP address. And the Airgap security appliance will have the DHCP proxy running on it to get the DHCP address from the server. And when they get the address, it will replace the net mask to a point-to-point net mask, as well as assigning its own IP address as the default gateway to that address, to the client. And with that, the client will think that it is the only device within their point-to-point network, and they need to send all the traffic to the gateway, the Airgap security device, to be able to reach any other devices in the network. So these are the function of the Airgap security appliances. As we can see, we have all these devices connecting to the same VLAN or the IP networks. But with the Airgap DHCP, we will be able to assign all the devices into its own subnet so that all the traffic coming from those devices will need to go through the Airgap security device before it can forward the traffic to the other devices in the network. And the policy will be applied on the Airgap security device so that when the traffic comes from a device, whether it is an IT device or an OT device, it will go through its corresponding policy. And the Airgap security appliance will determine whether the source and the destination can communicate with each other. And that creates the east-west firewall by creating the segment of one in your network. The second use case is the IT-OT segmentation. So during the DHCP onboarding of the devices, from the device signature, the Airgap security appliance can also know the device property, whether it's an IT device or an OT device. And automatically, we classify those devices into its corresponding policy group, whether it will be an IT security group or an OT security group, so that when we put those devices in the network, the corresponding IT device security group or the OT security group will be applied on that user. And the third use case is the automatic device discovery and classification. Once we do that classification, when we see the traffic, because all the traffic will need to go through the Airgap security appliance, we can keep track of the flows between the devices. And with the flow, it can show the users what devices are communicating among each other. And I'll tell you a personal story about this. Like in a previous company that I work for, we have the directory service on our intranet. And we used to need to go to the intranet to look up people in the, for their email addresses or phone numbers. But being an engineer, I know that the intranet actually has the connection to the backend LDAP server. So as an engineer, I write my own script to talk to the LDAP server to get the information of the users. But the LDAP server doesn't only give me those information. It actually, in the record, gives me more information that is not showing on the intranet directory service. It actually shows us the grade level of all the users. And at that time, we used to get our pay raise with a back pay. And for those people who have a promotion, they need to have, HR need to have the users recorded in the LDAP server on the retro pay day before the managers can notify the employee about their promotion. So using my script, we can actually tell that anyone is getting a promotion before they even know themselves. As you can know, like me and my friends are using that script to check out whether our friends or our enemies are having a promotion before they even know about it. So with the Airgap security device, if they find out that I can access the LDAP server with my own script, they will know that I actually don't have access to the LDAP server directly. And they will be able to have a policy to filter out my traffic to the LDAP server. But they didn't. So let's look at how it works in details. So we have the Zero Trust connector that connects to the Zero Trust Exchange for any northbound traffic security. But the Airgap security device is actually attached into the core L2, L3 switch. When the L2, like with the devices connecting to the different VLANs on the different floors, they cannot achieve the intra-VLAN security. Because even if they can create the policy on the L2, L3 switch, it can only be an inter-VLAN security policy. And even with the inter-VLAN security policy, it may be difficult to implement because we have the IT devices and the OT devices on the same segment. But with the insertion of the Airgap security device, when we take over the DHCP proxy for all the devices, we will be able to assign the point-to-point net mask and the default gateway of the Airgap security appliance to all the devices, so that when those devices need to send traffic to any other devices in the network, they need to send it to the Airgap security device. The Airgap security device will look up the policies to make sure that the source and the destination are allowed to talk to each other before forwarding the traffic to the destination. And that creates the east-west firewall that we never had before. And during this process, the Airgap security appliance also can find out the signature from the devices to know that it's an IT device or an OT device. And we can also integrate with third-party appliance, for example, the Microsoft AD server, to figure out that the user actually logs on to this device, and they can put into the user group policy in additional to the IT device policy and the OT device policy. And today, we need to have the Zero Trust SD-WAN connector and the Airgap security appliance in separate boxes. But going forward, as part of the Zscaler family, we want to integrate them into the same box to simplify the operations and management of that device. So like I said, the first use case is an east-west firewall installing in your network, with all the devices in the network being put into the segment of one, and they will be in their own subnet. And in order for them to talk to any devices in the network, they need to go through the Airgap security device. And the same policy can be applied to the same type of device. So we have the OT policy applied to the OT devices, as well as the IT device policy applied on the IT devices. And with the Airgap security appliance, it creates the east-west firewall for all the devices in the network. And with this solution, we actually do not need to install any agent on any of the device because we are using DHCP. So a lot of these OT devices don't allow any third-party applications being installed on them. And using DHCP, we have an agentless solution to do the east-west firewall. The Airgap security appliance also do the device recognition as well as the classification. So we know which device is an IT device and which device is an OT device so that we can put those in its corresponding security group. But look at the right-hand side. On the right-hand most device, that is actually an unknown MAC address. That can be a guest that is coming into the office for just one day and need network access. And because it is an unknown MAC address, the Airgap security appliance recognizes that it is an unknown MAC address and put it into the unknown security group. So with Wi-Fi, you may need to ask the users to go to the guest VLAN. But in our case, we actually don't need to create the guest VLAN or the guest IP subnet. The user can plug into any subnet and any VLAN. And because it is an unknown device, the Airgap security appliance will automatically put it into the Airgap guest access group. And they can even go to a different floor, get a different IP address. And because it is the same unknown MAC address, it will still get a guest access group. And with the device discovery and classification, we give our users the ability to visualize the network. What the devices are doing in the network, how much data are they sending, as well as the flow of the source and destination flow that we see from those devices. So that when the operator sees these graphs and charts, they will be able to visualize the network better. And with these information, hopefully we'll be able to create more secure policies onto their network. Okay, I'm not going to tell you all the different features on our system, but this is the result of our asking ourselves, how can we do better? And we look at the forwarding plane, control plane, and the management plane. On the forwarding plane, we enable routing processes so that within the network, we make sure that all the forwarding paths are optimal. And as a security device, we look at the security of the platform so that we make sure that we minimize ourselves as the surface of attack. And also, we will look into the manageability and make sure that we provide the users more information about the network, all the traffic within the network, so that they can create better policies within the network. Now, I'm going to talk about some of our customers. Flex is an engineering service firm that has a lot of factories in over 30 countries around the world. And their requirement is that they need to have the IT and OT devices in their factories be segmented. And those OT devices don't tolerate any third-party agents installed on them. So with the Airgap security appliance, with the DHCP proxy architecture, we make sure that all the devices will be put into the segment of one and have the east-west firewall policies acting on them. And also, well, because they are in the factory environment, they cannot tolerate any downtime. With the insertion of the Airgap security appliance, once the VLAN and the IP subnet is extended to the Airgap security device, all the devices on those VLANs will automatically get the benefit of the segment of one architecture and be part of the east-west firewall protection. Well, the second customer that we have is Tilly's. Tilly's is a prominent US apparel retailer in the US. They have about 250 retail shops across 33 states in the US. And their problem is that they need the security appliance to integrate with their authentication system. They have their own SSO and MFA security system that we need to integrate with. But that provides us with the user login information on the devices, so that when the user log on some device, it will be able to create the user segmentation policy group to segment the devices into different policy groups for the Airgap security appliance to apply the policy on. And they also have the granular segmentation requirement for the IT compliance. And because we put them into the segment of one segmentation, the IT compliance is met. From the first meeting, when they told us their requirements and we let them know what our solution is, we know that we are a perfect match for each other. So from the initial meeting to the validation and the deployment, it only took less than a week. And that was amazed me like too much. And so to end my presentation, I ask you this question. Would the agentless microsegmentation segment of one architecture benefit your network? Would the device discovery and classification of devices into the different policy groups and the ability to look into the network, to know what is going on your network, give you more information to create better policies to protect your network? Are you ready to take the next step to secure your network better? Yeah, thank you.